This conference will now be recorded.
Okay, cool. Let's start. This is a special session that we have for, actually, yeah, okay. So, yeah, I started from the old slide for this month, but intent is to talk about the double with a small factor. So this is actually something that Harvey and Anon might not be here. They kind of talk a little bit. Um, and then brought forward to me and think and ask how is it, and then I think it's a good idea. Then I forward it out to the CLA group, um, and then we also share the same information back in this month's OCP meeting. Since then, just for recap, this is what we have shared um, last week. Basically, this is actually the FLW dimension, and then it can support two small factor, and then why a single large form factor is a bit difficult for motherboard vendor to, because it's two different FLW motherboard. And then the idea from Harvey and on is more like, hey, what is this kind of dimension? Basically able to plug in to the FLW, and these are the power and proposal. I think more like details we can talk about, and some opens are there. Um, so from there we discuss a bit more, and then we realize that the the proposal that we talked about last week, I just coined it as option one. We can have different name if you want to. It's like when we discussed last week, we realized that that's unable to support a thumb screw. Um, and so this is after that I did have some discussion with Corey. And for those who doesn't know, Corey lead the FLW, um, the HPM workstream, and now he actually lead the uh, MHPM workstream also. But he has he had a lot of context of the FLW initially, how he changed to this version, and then as well as like in the HPM definition. So it's good to have him join so they can guide us through the reason and dimension and what are implications. So this is so certainly some surprise. It's like, oh, this doesn't have a time code support. Um, if we go with option one, and option one diameter does have a center to center gap of 81.55 millimeter. This is per FLW. And then if we will go with so-called option two, is we can support like a thumb screw, but then of course the gap will be wider. And currently there's a wider gap being documented in the Type 4 or Dino 4, and also Type 7 or Dino 7. So um, the, I think this is one area that we should look at. What should be the right answer? As such, I don't think there's an easy answer there. And then for other area, I think we can look in parallel instead of like two focus in just one factor. One factor is important, but I think we need some time to get there. And there are certain things that I think we need to work on in parallel is like for the dual wide small factor is all the bifurcation that we initially defined for large form factor, is it still applicable? And one use case, I would say major use case of this, the larger DSFF is for smart NIC. I think we should look at what area that we did not envision we want to add in for the smart NIC. Any new interfaces, for example, that we should consider. Because when we first deal the LFF is intend to be a higher speed NIC, but I don't think we have envisioned the smart NIC and how it evolved into like DPU, IPU, some other PU. use cases. So I think it's good to take a look whether there is any needs to be different from a pin assignment perspective for DSFF. Of course, it is hard, and any pin we need to add or something, we probably need to make it flex pin, because ultimately the goal is to able to put in two small factor and being compatible with it. So, but then I think it shouldn't prevent us from looking into it and make a conscious decision to support it or don't support it and see which one is more important.
So, Damien, this is Jason from Dell.
Yes, hey
In
Jason.
the last hey, in the last call, one of the statements I made toward the end, I want to raise here is I really think we should have DCMHS help with this and basically kick this off. From a perspective of Dell, this is what we recommend. As you brought up,
Mm-hmm.
Corey's here, Thomas is
Yep.
here. They were some of the original groups, and at the time when the NIC was being origined, there wasn't a server sort of specific look. Now we have that. We have a
Mm-hmm.
server group that's looking at the server aspects of things.
Yeah, I think with this, I think the form factor has to work in co together hand in hand, like co-develop with a server, right? If a NIC doesn't have a server, it doesn't work. If a server doesn't have NIC, well, server will have a PCI NIC if you don't have this. But but anyway, yeah, I do believe yes, I do align with you. Like, uh, yeah, we need to work together with the server, and that's why there's actually some discussion offline, and in the DCMHS email chat. This is about how do we work on this, and we also work. Once we get some alignment that what our thought is, we also need to go present back into the MHPM meeting, right? So yeah, we need to work together. It's not something that we can just design and develop single-handedly. I mean, we tried with lateral factor, it did not work very well, right? So let's not repeat
Yeah, if
that.
you recall back in when we first made OCP Nick through 3.0, I made a couple comments of asking, hey, can we make a chassis spec? It didn't occur, so we try to wrap up as much of the chassis related items that was not vendor specific into the main spec, but having the overall arching chassis specifications that we have today, that might be a great place to start.
Mm.
Yeah, I think yeah, to build on what Jason was saying, I think we could certainly queue this up within the MHS work groups to kind of wade through. I mean, what you described earlier, I think, was pretty accurate, Damien. I think we need to wade through the system constraints and goals that went into the current HPM specs and the resulting constraints on the OCP NIC in particular, right?
Mm-hmm.
We need to wade through that on the different HPM form factors, right? So there's a very specific set of reasons
Mm-hmm.
why the FLW spec only supports the pitch for the internal latch version.
Mm-hmm.
And I would say that like in the DNO, like the Type 4 spec, I think we called it the platform custom zone. It just kind of happened to have space, and so it was
Mm-hmm.
kind of opportunistically spaced
Yeah.
for thumb screw. Um, so I do think it's critical that we keep the any output of OCP NIC needs to have a good alignment and tie-in with the MHS HPM plan. And so yeah, I support bringing this in. It's not 100%. It's kind of a hard problem, right, to wade through the couple different constraints. So
Yeah.
I don't know what you were. I think you forgot the words you
Yeah.
used a while ago about identifying this group's goals, bringing it into MHS. I personally view like we should do those in parallel and compare notes, right? So if
Yeah.
the participants in this work group, I don't know how many um, platform producers we have in this work group that are different than MHS. Um, but it would be good to establish for both the platform producers viewpoints as well as the device producers. If there's any particular technical reason or market reasons they see, it should be aligned. This definition might be aligned one way or the other.
Yeah. I would say this group will really need to weigh in into two things like uh, 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 the next side, like more device side, are you okay with no thumb screw support? Second one is more like, is there a reason to have a wider gap, or like basically
Yeah,
try to weigh in instead of like from of course from the system side is like the smaller the better is always so
yeah,
it's like is there more like these two groups need to come down together and see where do we align on, and I'm sure there will be a trade-off between the two.
yeah, yeah. That'd be great. If we ask the device providers that question, like you just asked, that would be good to get collective feedback on that.
Yeah.
And then if there's any unique system providers here, you provide that feedback, and then let's go ask the similarly relevant questions within MHS. Try to establish the priorities and constraints there, and then compare notes on how close we are to some type of alignment.
One other question I have is whether
Yes,
or not you can have two different connectors, or whether the tolerances are such that in order to locate the gold fingers within the connectors properly, that has to be a single long connector. And if so, is there any problem with creating such an item?
This is the same problem with the current LSS, right?
Yeah, I think
Yeah.
that's
it
solved.
actually is. I think
Yeah.
Amphenol looked into this before, and we realized that there are some improvement maybe needed.
Yeah, I mean, I'd be surprised if you don't need a single connector, and I just don't know whether a single connector of that length is something that would be a problem.
Yeah.
But
I remember asking the connector vendors years ago if a single connector can be generated to avoid the tolerance issue between having two connectors for LSS. At that time, they were not wanting to make a single connector.
Yeah, it
Yeah,
was a pretty long single connector.
so they came back and said that having two separate connectors wasn't an issue. Or what
No,
happened?
Didn't
Because
somebody do a tolerance analysis years ago?
Z, can you speak up? Yeah, I think Z trying to answer from a connector perspective, connect vendor perspective.
yeah. So I think I think first of all, yeah, for doing the single connect with to include two 4C plus, it is too long, and it will be very difficult for manufacturer to control the shape of the connector, right? It will have some twisting, and you have difficult to control the coplanar, and you will lead the high defect rate on the soldering process. And if we say doing the two connector, and actually, yeah, we worked with Meta a little bit. I think maybe 1 year ago, and we did a study, tolerance study, and we are seeing the high DPPM if we follow the current NIC 3.0 spec. Means the in the current NIC 3.0 spec, the tolerance between these two connectors is pretty loose, and also the basically also means the tolerance between the two golden finger, right? The separate golden finger section for 4C. The tolerance between them are pretty loose, and the issue is we may observe the interference when the card mate to the two connector at the same time. So we were thinking, the connector placement and the golden finger section, the position tolerance needed to be tightened. And one example actually is we look at the PEC-FF in the senior SFF spec, right? They had very tight tolerance between two connectors and between two golden finger sections.
Maybe to summarize the question is that it is a difficult problem. Tolerance, you have to do something, maybe call it atypical, to address this. The single connector solution is actually a worse result than I think is what Z is reporting back, is that's the single connector would not yield the solution we need. So it's probably a different solution in terms of tolerancing and manufacturing recipe.
Yeah, and I think almost a year ago when Z come to me, and then we did share some example what Meta do internally, not using as a NIC but using two connector, sort of similar use cases. And then we were surprised to see what I think these the PV analysis is very high, and then but we didn't get report like from our factory that it very bad. So we went through the thinking, and apparently there are some tolerance was tightened within Meta and the ODM design that we are not aware of. That kind of avoided the problem. So if we go down this route of speccing this, we may want to relook into that tolerance analysis. And I think I can get the meta mechanical engineer to come back to talk about what we did and how do we avoid the problems.
Okay, I mean, I was just raising the issue because I'd hate us to go down the long path of creating something that isn't manufacturable.
Yes.
Yeah, I think it's solvable. I know on the Dell side we solved for similar application, and it took some special efforts in terms of tolerance and manufacturing to make it work. Okay. So we can maybe help with that too, David.
Yeah, thanks. Sorry. Yeah. Okay. So I think the one have looked into from a NIC perspective, the one have looked into probably some dimension, and from a NIC perspective, one is probably NVIDIA. Unknown, you want to give some comment and thoughts about um how does it affect you in terms of no thumb screw and this dimension?
So I think, the thumb screw or no thumb screw question is more from a system vendor point of view. For us as a NIC vendor, we basically, provide all the SKUs that are required by the market. And yeah, this DSFF form factor can have a thumb screw. It's only that the middle SFF will not be able to fit. So, and I think you talked about it already. So I don't have anything further to add.
How about dimension of this design? Like this is good enough.
Yeah, so this is good enough for what,
Good
I
enough
think,
for like
yeah,
because you came with the dimension proposal. I'm sure you have looked into your at least next two generation of
yes,
solution kind of need to be within this space, and likely you target at least 800G or maybe 1.6T, maybe from looking from that kind of perspective.
yeah. So I can share with you that
And also the team. Yeah.
our current solutions For 800 gig, we're still investigating whether we can converge into an SFF, TSFF, whatever, but an SFF volume. I mean, we can converge electrically, layout-wise, but the question is whether we can converge thermally within a reasonable boundary condition, right? Because I mean, we have the real estate, we can fit it in the card. We have a relatively compact design, but the problem is, cooling an 800 gigabit module, cooling an 800 gigabit capable NIC. Now, the second thing is that once you go 800 gigabit NIC, but Gen 6 servers from the host side are not available at this moment and will not be available for quite a while until we, when we roll out 800 gigabit, we do see the need to break out 32 lanes PCIe of Gen 5. And that's where the SFF, breaks, right? So having a 32 lanes, whether that's the old school LFF or this new form factor, provides us both the ability to break out more PCIe lanes and the ability to more effectively cool the NIC IC and the modules. Now, another thing is when you go to more advanced NIC solutions like what we call a DPU, or our friends at Intel call IPU, where you have a more elaborated SoC with DDRs, and that's where an SFF definitely will not converge, even electrically, just layout-wise, it will be very challenging, right? So that's where we have to go to either an LFF or this new DSFF. Now, so from our point of view, if I have to look at it only from our server manufacturer, from a NIC vendor point of view, I mean, we don't really care. We probably can manage with the real estate of an LFF. The additional real estate that the DSFF provides us, just because it's a little bit wider, is not a game changer. It's nice to have. But what we are really looking into is the adoption from the market and the server manufacturer. If going with this form factor will allow us to converge into more systems, then that is our end goal for this initiative.
Yeah, so I think you answered a key point. Like basically, from NVIDIA perspective, even our existing LFF is good enough for space. So this DSF option 1 give you more space, which is good but not necessarily required. So the option 2 give you even more space because the gap is wider between the two. So it's actually not required, but it's more like you have more space, but it's not necessarily you are saying like this is needed. Sorry, not necessarily saying option 2 is needed. So option 1 is good enough from already from your perspective, from a space perspective.
Again, I would say there is option 0, right? Option 0 is current LFF. Okay.
Yeah, that's true.
And
but honestly, no, I think I'm not sure whether this is really. I feel like option 0 is PCIe. We can debate why it's option 0.
That's maybe -1. Okay. I'm trying to say, staying within the OCP boundaries. I'm just saying between option 1 and option 2. I mean, making it even wider. From our perspective, the more real estate we have, we can go crazy with the solution, right? We can. I mean, it does add a little bit cost to the PCB because the PCB is bigger, and if you just have a bigger PCB and you don't need it, you're just wasting FR4, right? But putting that aside and assuming that's negligible, then I mean, yeah, it's mainly for the community to decide what will make the adoption of this new form factor better. And again, if it doesn't make it better, then we just might as well stay with the existing LFF, maybe define a tall LFF, and that's all, right? I mean, the motivation here is to find a way that will increase the adoption of this new large form factor.
Yeah, makes sense. Like, honestly, I wouldn't hold my breath against LFF. Like, I feel like if that is our answer, the chances is not high. We might as well say something else.
Yeah. Damien, maybe I can add to this a little bit.
Yes, is it Paul?
Maybe yes. Hey, this is Paul Kaplan. Yes.
Yeah, sorry now.
My voice is a little bit familiar to you. Good, thanks for asking.
Mm.
You know, I think if I look at LFF, not only do we have our existing adoption concerns, but in this, you know, Intel's IPU space, I think we do see that even LFF in our sort of most advanced ideas, where we're thinking about getting all the features in such a card, is too small for that.
Oh.
When I try to, you know,
Uh-huh.
compress everything I want to fit into an IPU card, including timing features like synchronous Ethernet and DPLs, all the DDR I want to fit, and the largest modules, whether that be dual QSFP or even OSFP, like we've been talking about. And I want all that in a card, that most full feature card. I can't even fit that in LFF. And I think this DSFF does open that further, you know, get more of those features in a card compared to LFF.
Okay, since your case is a bit different from NVIDIA, so NVIDIA is large enough is good enough. So then I will ask the question again: is option 1 versus option 2 any different from you?
I have to research more.
Yeah, you can take a look
I
at
can't
that.
answer that yet today.
Yeah,
but I can say about LFF that we have ideas that go bigger than LFF.
okay, good to know.
Yeah, just to add
Okay,
Paul
that's a
and
good point. I just want to add to that. I mean, the fact that I said that we currently think that we can converge, you know, doesn't mean that the roadmap ends there. And as Paul mentioned, there are a lot of features being considered into this type of stuff. Having more real estate is always good. Is always good.
Yeah, but also
we all
like
want real estate. And finally, you know, it improves cost, right? Sometimes we can say, oh, look, I can, you know, with every bit of real estate you give us, and I know you don't want to give us real estate, and that's okay. But you know, the more real estate we get, we can improve costs, right? Choose that little better cost component with a little more real estate too.
So I guess the question that this on this slide here, this is the 157 millimeter dimension. And I guess if there was a thumb screw line, that number would get a little bit bigger, but it's just a couple millimeters. So it'd be good to get Paul, your feedback and the NVIDIA feedback on, hey, does that extra millimeter or two, does it matter? Yeah, or does it outweigh whatever feedback we might get in terms of the system provider environment?
I really think fitting into the system with this thumb screw issue is outweighs this kind of marginal
couple millimeters
kind of thing. Yeah.
I agree.
Okay. Hey, one tiny clarification, Damien, on your image here, the top arrow that says no thumb screw, technically that can be a thumb screw. It's the middle one that can't be. So in the base spec, like for folks who are implementing a single OCP NIC, it can be a thumb screw. It's the pitch to that middle one. The middle one is prevented. So I don't want to.
Okay. So this one, this one, so-called, is it right?
Yeah. Yes, that's
this
right.
Is a bit smaller. So this is a bit smaller.
Yeah, that's right. Because there's a little bit of space to the, I guess, to the top of the picture, and where the power supply bay is. So that upper OCP NIC, which is the primary and required NIC, thumb screw is possible there. It's that second one, that middle one is called the platform custom zone, and we just define a couple of different options. Like you could put boot devices, or you could put an OCP NIC there, but it's the resulting space. That means that middle one is the only no thumb screw space. So, all that said, that doesn't change the dimensions on the right. I just wanted to portray the situation accurately.
Yes, I think that helps. Actually, initially I thought both are not possible. So thanks for correcting me. Yeah, but by the way, as I understand, the ejector latch is actually a little bit smaller. So from FAW or the MHPM, have you looked into whether ejector latch is possible?
I don't think we did. We should bring that up. I don't think any of the participants at the time were using ejector latch or pushing forward. So I just
Yeah,
I do
but
not
I remember all the
recall.
CAD I have seen is all thumb screw because thumb screw is more
Yeah,
popular. But I think
yeah,
it might also change some system vendor perspective. Like,
it
okay, if
could.
you
Yeah,
do thumb screw, okay,
we should put those options on the table and just
yeah,
rethink where we're
yeah.
at. Yeah,
Instead of saying that it's just internal latch, for example, like
yeah,
like it's good to find out, see
yeah,
what
yeah.
other people.
We had a brief chat on that internally at Dell as well. It was like, hey, does the latching actually help maybe mitigate this concern with this pitch?
Mm,
So
Right.
yeah,
yeah, and I
Well, that
think this
let
is
let me just
possible.
say too. Hey, Damon, let
Yes,
me just
yes.
say too, because let's go back to our option one too. There and back to that option zero. So the
Mm-hmm.
option zero gives the LFF gives you more space. It gives you more lanes. You know, this DSF gives us more space, more lanes, and then the option for the two SFs with one having to at least be an internal bracket, and then your option two is trying to add a case for the thumb screws that
Yeah.
just we need to just at least understand that there has been not only a reason just because of the different motherboard. If there's enough business case to require more lanes, why haven't people been really looking at the LFF? But while that personally I'm not the biggest fan of LFF, from a NIC group,
Mm,
it's still something we actively support. And so we just need to understand that even though we're talking about this option one, option two,
mm-hmm.
it really needs to free from a perspective of what LFF doesn't give us that is preventing that ability to be adopted.
Yeah,
Yes.
and what's basically happening is, as the NVIDIA folks have pointed out, we're reaching the case where our link or our fabric speeds are now eclipsing 400 and moving towards 800 gig. And
Yes.
with that, we really need the 32 lanes if we're using PCI Gen 5. And that's where we started looking. We said, well, golly gee, I can see people making the motherboard that's pictured there on the left in the option one
Mm-hmm.
picture. Because, hey, I
Yep.
could put in one or two, standard, NIC cards, or I could put,
Hmm.
so it makes sense that a motherboard manufacturer would make that because they're not locking anything out. When they move to the LFF, then they end up with this kind of strange center pocket
Yes.
you can't do anything with unless you
Yep.
have a LFF only card. That's why we're
So
proposing the
right. But
dual.
so in the current solution before LFF, what do people do? What they do is instead of on the baseboard as an SFF or LFF, they're moving it to the riser. So the use case of what was going to be desired that eventually gets killed in the LFF moves up to the riser. So what we have to do if we're going to go forward with this too is we have
Mm,
to make the use case compelling enough to include the DSF because the LFF wasn't enough. Like I said, because the alternative is, well, you can use LFF or you can move it up to the riser and somehow contend it on a riser card with a chem card.
And
is
with a
the chem
cam
card
and an
32? Yes, Arnold. Go
yeah,
ahead.
so I just want to continue the same thought process. So yeah, today when we have customers that want to use 32 lanes, yeah, then they have to go to a cam card, but the cam card is also by 16. But what we have is like an
Yes.
expansion auxiliary connection to either to another auxiliary card which is plugged into another adjacent slot, or you can theoretically connect it to the Razer or to the motherboard, or whatever, either internal cabling. But it's also not standard. I think what's compelling here is that we can come up with, or we already came up with, the LFF was the first standard PCIe card that had 32 lanes. Has very small or zero adoption, but I mean
Mm-hmm.
it's a good thing, right? So
Yeah, it
that,
was the
that's
right
that's
idea.
something good.
Yeah, that's how I
Yeah.
view it. It was the right idea. Let's just fix the form factor so that motherboard manufacturers are compelled to make something where we can get 32 lanes and have, as I pointed out, a standard card that people can buy and plugs in without having to have cables and jumpers to get
Mm-hmm.
to get the additional lanes.
Yeah. And then within the DCMHS, we also have some CLA group, right? Like, we can go and ask like how compelling it is, and obviously HPE is, because HPE is one of the member there. Yeah, we can go and ask the compelling reason. I felt this have a better chance than this, the large form factor, but we can go and get the answer. And honestly, I think it is hard for a spec to serve everybody, because everybody has different use cases, especially you talk about at this time 800G, there's really not that many that needing that kind of bandwidth, but eventually you will get there. So as long as we have like maybe 2 or 3 companies willing to do it, I felt that is a good enough reason to have it. We probably don't need to say we need a whole kitchen sink, we need everyone to buy in for this particular one, because it's actually a niche use case. 800G, not a lot of people are talking about 50G NIC, 25G NIC at this time. So yeah, so that's my thought. Like, it's a pretty good idea, and we should get it up and running. Actually, one challenge that I see, I'm not sure whether this is the group to talk about it, is like this FLW. If we were to implement two small factor here, we kind of lack a space for so-called a boot drive or so. Yeah, I actually wonder how people actually solve this, like having some boot drive somewhere.
Yeah, we either put them in a different location in the chassis, or you can fly them over the top of these of the NIC
Mm-hmm.
cards.
Mm-hmm. Yeah.
Yeah, that's why in the FLW spec we
Yeah.
ended up
Device
defining 2 or
customization
3
zone.
different, just for those reasons. There was system provider use cases that were just different, right? And this,
Mm-hmm.
we identified the opportunities that that zone could be used in a couple different ways. So we just provided some optional references for how to use that zone.
Mm-hmm. Yeah. Yeah. One benefit I kind of see from LFF, it's not that I support this form factor. It's more like you can have one good drive, like this good enough for 1 or 2 here in this blank space. But anyway, I'm sure there's a way to solve it this differently from the 2SFF. Okay, we have a bit of time. I think we should form factor. I think the next step is to take it to the MHPM Corey to talk about it. There is really seems to at this time I'll call Intel need to come back and see whether there is a difference between option 2 and option 1. What I hear so far, there doesn't seem to be a need that's driving to it yet, but we'll give Intel a little bit of time to go back and study. And we will probably present these 2 cases to the HPM group and get mostly the system vendor feedback. I think that is a very important part of it. And for other NIC,
Damien, maybe, I'm sorry, maybe I missed the first 5-10 minutes of the meeting, but
yes, I know.
option 2, does it
Yeah,
even fit inside a standard? I mean, the fact that you space out, though, I can imagine that the fact they did it so cramped because they needed a room for their other stuff on the card. What's the trade-off of this? Apart from
yeah,
the size of the card itself, what trade-offs on the system motherboard does this impose?
yeah. I think FLW, actually I remember, if I'm not mistaken, is actually does have Tham support like initially, but we made just some adjustment for one particular company. It's not a, this is a record meeting, I don't want to name it for sure. And then the capability kind of goes away. So it's a trade-off, I think, with whatever feature we wanted to make versus the more original or the earlier version of FLW. So there's
No,
some
I
trade-off
mean,
that we made.
no, for example, if I look at the connect the olive green connector on the top, right? What does it? Where does it go to a drive? What's
These
Oh, on the
two,
very top is power
this one
supply.
is power supply. These two bottom are
power
actually
supply?
the CRPS power supply.
Right. So I can imagine that if you push the upper PCI SFF, sorry, up, then you don't have room for that? Or is there enough clearance there? That's what I'm trying to understand.
Yeah, I think where he's going is if they were to move to the wider spacing, so you could support a thumb screw on the middle Type 3 when you put two single Type 3s in.
I'm trying to say that it's probably not free.
No,
Yeah.
but I mean, but then you'll need to enlarge the y-axis of the entire mainboard, won't you?
Yeah, it might come at a cost. Maybe like this particular DCSCM might not have a thumb screw. I don't know how we're gonna solve it yet, but first of all, we just see what do we need. Then we go and see how do we solve it.
Yeah.
There,
Well, and that's why I wanted to at least go back just to
Yeah.
restate that LFF gives you space and it gives you the extra 16 lanes. That the option one gives you space, lanes, and the ability to do two SFFs if at least one of them was internal lock. And Lenovo's not here, but I know they've expressed public concern about not being able to support two thumb screws.
Yeah, I understand. I'm just saying whether the other alternative is even the option two, whether that's even something we can propose, or
Is
it
option is option 2 even viable to make a
yeah.
chassis that does that?
It
Right.
depends which chassis. Like I think there are chassis that is for Dino 4, like Dino 7. It is possible, but we're talking about the FW chassis based on what we spec today. It's not.
And
there were
how
some
about
specific.
Yeah. Corey, go ahead.
Sorry.
sorry,
Yeah.
how please go, Corey.
Okay. There. Just the background was there was some specific system constructions, overall features and layouts that were assumed that resulted in this FLW layout. So that's why I mentioned earlier there were some constraints that system providers kind of ended up agreeing on that resulted in this board outline and the pitch of the OCP NICs. Whereas in the DNO spec, that was in the option 2, the DNO spec didn't have those exact same constraints, and it was a little bit more opportunistic that the pitch could be widened.
I mean, don't we already have the answer in that somebody is already using thumb screws, or are they not using two OCP3 NICs in whatever they're doing? I mean, it's worth checking, obviously, but the fact that thumb screw OCPs are relatively common means that somebody's solved how to use, I assume, multiple ones within a chassis.
I don't think that assumption can be made. I mean, someone maybe, yes, but not necessarily with FLW spec.
Okay.
This is specific to the OCP, the DCMHS, standardized form factors.
How about, are we open to a possibility to go into the DCSCM spec and defining an opposite side thumb screw? Or is it a wild idea? Because that way you can move the middle OCP a little bit downwards. But that creates some inconsistency with the location of the thumb screw. But since the DCSCM is like a different creature altogether, maybe that's possible.
Yeah, it might be. I'm actually trying to remember.
I think someone
Dave.
share internal log of the CSCM.
Yeah, there's an
I
internal
forgot
log. Actually, I'm not sure that the actual thumb screw DCSCM is supported in the FLW spec, and I have forgotten. I'm gonna have to go back and look. I don't know if see Dave from HP he recalls.
You're saying that the image here is not even realistic.
It might. It may not be.
I would say there is actually a version of DCSM has thumb screw because that is the one
Yeah, there is.
that I'm using.
I
Yeah.
think it comes back to that center zone being a custom zone. So like if you didn't have an OCP NIC in that center zone, then you could put a thumb screw on the DCSCM. So I think there's like kind of a gray area on depending on which options you pick in that middle zone. The different options for DCSCM is available.
Corey, this is Dave. That's how I remember it as well.
Okay.
So you're saying that if somebody in the custom zone decided to put a middle OCP SFF, then it cannot support the DCSCM with a thumb screw anyway.
I believe that is the
Yeah.
case.
Mm-hmm.
Makes sense. Makes sense.
Yeah, I think that's true.
Maybe
one
those are
other
some of the
general
minor details we need to work on before we decide the pitch. Because for us, if it was initially it's just like 2 single car, we don't really have to care. But if you want to do 1 single car, then we have to care about those pitch and what the right pitch to be.
I think there's a compelling that overall the thumb screw in any slot is compelling and desirable for many of our customers, right? People ask for it. So to create, if we make it so that we have places where you can't have thumb screws, we exclude the people who are really interested in that external serviceability that the thumb screw provides.
Yeah. Yeah, Paul, it's not only that. I have to add that, for example, when NVIDIA was asked to, consolidate its portfolio and, kind of minimize the SKUs offering, we decided to have all of our generic OCP cards be only with thumb screw because that's kind of the most common denominator. Yeah, we did have options to replace the bracket, and we did have some customized SKUs for Dell and such. But again, the vast majority of the generic offering is with thumb screw. If you kind of go and buy off the shelf.
Yeah, that's also part of the reason why I bring up like thumb screw seems to be an important thing. But then we need the system vendor, NIC vendor side to kind of tell her. I really need the system vendor to say thumb screw is important. I heard from Lenovo like from last week call, but like and also yeah, maybe even who else. And very unfortunately, I think Lenovo is not participating in the DCMHS CLA group currently. So I guess I have to represent their voice when I present.
Well, yeah, in
the
some ways I was trying to at least state what they stated too, because honestly, right now Dell is interested in this. We are interested in what we're currently calling option one. We definitely want to continue investigating and talking about this.
Yeah, and we do, but the fact that we have inconsistency within the HPM specs, we need to resolve, I think, or figure out a plan there.
Yeah, also like how this yeah, definitely good, right? Because now it's like MHPM. The intent is to have one chassis you can put everything, at least ideally.
Yeah.
And then yeah, so the inconsistency on the location is now probably something we have to look at. In the MHPM.
This opportunity was just never really presented itself. So so it just hasn't been discussed in HPM. So we need to think about it.
They have not been discussed, and once it's been discussed, it's now like okay, which is the right direction.
If we only had a way to remove the pull tab and plug the one thumb screw onto the other OCP, we could have staggered them.
I think it should be. I mean, we were just brainstorming around here, and maybe it should be discussed. I think our Damien, whoever brought up the cam latch approach, but maybe there is a way to that idea in terms of modifying the pull tab approach, or is there some improvements that we can be made for the adoption of the cam latch that we can shift toward the thumb screw. I think those ideas should be put on the table. I haven't looked at the possibilities in detail or dimensions, but
maybe when you say cam latch, you mean the ejector latch?
Yeah, the third OCP NIC option of having the whatever you call it, the camera ejector. Because I get what Paul was saying earlier about hey, Paul sees a bunch of customers that already have thumb screw. Paul wants to be able to present the most, largest addressable market. The other side of the coin is the bigger that footprint, the harder it is going to be a fit in every single system, right? So you also got to weigh that against the motivation to make the footprint for these devices smaller in common as opposed to be slightly larger in common. So that's our dilemma.
Yeah, and if it really come down to this, right, then we have to see why the thumb screw are being more popular despite being wider, and then what thing we can do to address the need.
Yeah, I kind of think. I mean, I remember from Dell's point of view, in the early days, that there was some attributes to the cam latch, to the design, that we had concerns with productizing. So I know that we were for any pluggable, externally accessible versions, that we were in favor of the thumb screw over the latch. So maybe that's a good opportunity within this work group, is to look at the cam latch version. Could it be accomplished on the same pitch as the internal latch? And is there any concerns that need to be addressed that allow the community to be comfortable with any of the fans or those who are in favor of the thumb screw? Is there a way to morph the latch to address any concerns and be a usable alternative?
Yeah. If we were to go with no thumb screw, then we had to address those, like how to address people that need the thumb screw or want the thumb screw. At least need the thumb screw is, at least we need to have surprise. Want the thumb screw sometimes desire is hard to change, but at least the need the thumb screw is something we need to address what are the needs are. Okay. 4 more minutes. So I
Hey,
think next
Damien.
week is, yes.
Hey, Damien, sorry.
Yes, my line.
Instead of having a double small form factor, how about have we considered to staking 2 small form factor and have a portable connector to making a 32 lanes?
Like, you mean like, okay, top,
Yeah,
okay, stack
on
them,
top
right?
of the
Right.
yeah, staking 2, because we will have a riser on top of the small form factor 1, and how the riser will provide the flexibility so that we can leverage the riser concept to change the design, change the cam slot to another OCP small form factor slot, and have a staking small form factor design, so that we can have a portable connector to connect these 2 small form factor together to have 32 lanes.
For this, I think probably Nick Vendor can answer the.
Well, the real estate that you will
Yeah.
gain, the problem is the real estate that you will gain from this creative idea will maybe different, maybe difficult to harvest. I mean, I'm just thinking, if I need more room on my board, so let's put the 32 lanes aside. It will solve the 32 lanes. Let's assume there are some signal integrity challenges with putting this board to board, but let's assume that that's fixed, that's solvable. Then the other thing that this larger form factor is aiming to solve is the real estate. However, the real estate is for like stuff like DDRs or just bigger chips or bigger ICs, and then this board-to-board interface will probably not be. You don't want to carry over these type of signals between them. So I don't see how this can solve, but maybe Paul can have
I think the portable connector just carry the 16 PCIe lanes to the, let's say, bottom one, and all the DRAM and the ASIC network ASIC are placed in the bottom one, and the upper one just
Yeah.
provide another space for the either PCIe lanes or another QSP OSFP ports.
So as I said, it doesn't solve the real estate problem because this OSFP cannot be located on a different board. It has to be adjacent to the controller IC. And all the other components will have to be crammed in that lower or first SFF. So it doesn't solve the form factor, the real estate concern. It will only solve and I could potentially even say it will worsen the real estate because you'll need space for that board to board, and it will eat up space, not to mention block airflow. So again, I initially, from a gut feeling, I don't see how this can solve our challenges.
Yeah, I think I agree with you, and I'd further say I'm not even sure we can solve the PCIe signal integrity problem. I think that's pretty.
I was being generous, yeah.
Okay. Yeah, but the things we want to do with the board area include DDR, more high-speed Ethernet lanes. Neither of those really traverse a board-to-board connector very well. Even if I can put my, say, VRs or something on the other one, I still have losses and voltage margining that I would eat into. So there's very few things I can put on the other board to really help.
I agree.
Okay, we are out of time. Good discussion. Can I talk about next week agenda? So I think we need to look at the bifurcation area. If I'm not mistaken, Yuval is still here. Yuval and Thomas are actually I would say the master of these two. A lot of you are looking at like, what is this? I'll get lost within the table. Can we look at that part? Whether that is still applicable? Thomas, do you think you can work with Yuval on this? He kind of dropped. He was here earlier.
I have to drop as well, sorry.
Yep. So yeah, so I think maybe Damien, well, let's talk in the intervening time. We can come up with a present. I know we have new topologies that we have since that original large form factor effort that I think need to be considered from the perspective of our products. So
Okay.
we'll present those. I don't know if I could be ready in a week though, so maybe we'll have to kind of get offline to see that. But maybe we'll try to. We can at least start the conversation though and get the basic
Yes,
ideas.
I think we should at least start the conversation and and then if you want to change it, then I think there are probably a lot more input coming.
That's right. Yep, that's right. Yeah, so let's try and give the basic ideas of those topologies next week. I think we can. Thomas, I can work on that.
Okay, cool. I think Thomas somehow the audio is not there. Yeah, thanks, folks.
Thomas is moving around right now. He had to be on a cell phone, so maybe he's not hearing us.
Yes, he told me that. So cool. Thanks, Paul. And good discussion. I'll write down some minutes and send it out. Cool. Bye, folks. Take care.
Thank you.
Bye bye.